Hey guys, so we're going to be working on the second section of chapter 1. Today we're going to be talking about irrational numbers. So make sure you have your notebook ready and opened and that you are taking good notes. Remember, if you do not have notes in class, I will not help you. So let's go ahead and jump in. Right here are your vocabulary terms. So this is where you want to pause the video and make sure you copy all of these things down. A perfect square is a number that is the square of a whole number, and the square root of a number is another number that when multiplied by itself is equal to that given number. Now these shouldn't be new terms to you. You should have heard of them before. When we're talking about perfect squares right here, we're talking about values that do not include repeating decimals or anything like that. A perfect square is a number where square is a whole number. The square root is going to be some number that when multiplied by itself gives you the, I lost my train of thought. The square root of number is another number when multiplied by itself gives you another number. And there's a couple ways this shows up, so let's take a look at those. So here it says find the two square roots of 25. You may be saying to yourself, wait a second, there's only one square root of 25. How on earth are there two? Well, this is where remembering your multiplication rules are going to be very, very helpful to you. If you know your multiplication facts, you'll know that the first square root of 25 is going to be 5. The reason that is because 5 times 5 equals 25. But here it says two square roots, and no, it's not talking about the 5 and the 5 are the 2. There's another number that when multiplied by itself is going to equal 25, and that is the number negative 5. And the reason being is if you have a negative times a negative, if you remember your multiplication rules with integers, that equals a positive. Okay, so make sure again that you've copied this down into your notebook. If you got to pause to do that, please do so. But the two values for this are going to be 5 and negative 5. Those are the two perfect square roots. So right here I have a couple examples for you to try. So go ahead and pause and try those on your own, and then when you're finished, unpause, and the answers will be revealed to you. Okay, so here it says find the square roots of each of the number. The first one for 36 is going to be 6 and negative 6. So if you didn't get that, go back and figure out why. Square root of 1 is going to be 1 and negative 1. And then the square root of 1/16 is going to be 1/4 and negative 1/4. All right, so hopefully you got those. If not, try to find your mistake. If you did get them, great. If you can't find your mistake, make sure that you ask me the next time I see you in class. So let's go on to our next example here. So here we're finding square roots of perfect squares. This is just notes. This is important information. So you want to pause and write all of this down. It says the symbol, this is called a radical. All right, it's not written out in your notes. You may want to make note of that. Here, I'll write it right here. This is the radical symbol. And it's not like Ninja Turtles radical. It's just called the radical. Radical means the square root of a number. If a sign is not included, you could assume it's referring to the positive square root. So that radical 9 means the non-negative square root of 9, which would be 3. If there is a negative in front of the symbol, then it's looking for the negative square root. So that negative radical 9 would mean negative 3. All right, so you got to pay attention to those signs. Here's how it may play out. It says, or wait, we're going to look at a different problem. Estimating the value of radical 28 to the nearest integer and the nearest tenth. So there's two problems within that. So make sure that you're noticing both of them. The first thing that you'll want to do on this is think of this in terms of a number line. So if this is my number line right here, I have the number 4. If I start out with 4, the equivalent of 4 is going to be radical 16. Now the reason that is because the square root of 16 is 4. These two numbers are the same thing. This is the simplified version of this. So if I continue going, the next number would be 5. The perfect square of 5 is 25. So the square root of 25 is the same as 5. And you can see as I increase on my number line, I'm getting closer to this radical 28, but I'm not quite there. So I'd go up to the next number, and that would be 6. And that is the same thing as radical 36. Okay, so I've passed the radical 28. So if I'm doing an estimate, it's going to be somewhere in between radical 25 and radical 36. In other words, between 5 and 6. Now you have to think to yourself, radical 28 is a little bit closer to radical 25 than it is to 36. So if I'm rounding this to the nearest integer, I would say it's going to be 5. It's closer to the 5 value than it is to 6. So the nearest integer we would say is 5. Okay, so to find it to the nearest tenth, we're going to use a very, very similar strategy where we're going to have a number line, but we're starting with numbers that are a little bit different than these integers. So instead of 5, I'm going to start with, we know it's not 5 because that's 25. So we're going to go to this first number, which we're going to say is 5.1. Well, if I square 5.1, and here you may want to use a calculator, you could write it out by hand, you get 26.01. All right, so radical 26.01 is the same thing as 5.1 squared. That's not quite to the 28. I'm looking for one that's really close to that. So 5.1 isn't going to be right. And again, I'm picking ones with the tenth because that's what I'm rounding to. So I go up to the next one and I try 5.2. This is kind of a guess and check method here. And that is 27.04. And maybe you're possibly noticing the beginning of a pattern. Maybe not. I don't know. So here, 27.04, not quite to radical 28, but you can see that the numbers here are getting closer. So let's go up to my next tenth, which would be 5.3. And 5.3 is 28.09, and that is darn near close to radical 28. So we could go on to another one if we keep going to get 5.4, and hopefully by this point you see the pattern, and that's going to be 29.16. Kind of running out of room there on my number line. But you're looking for the one that's the closest to radical 28. Well, clearly this one is very, very close to radical 28. It's going to be somewhere right in this area on the number line. So if I'm looking for the nearest tenth, it has to be the 5.3, or 5 3/10. So rounded to the nearest tenth is that one. So here's one for you to try on your own. Go ahead and pause and try that problem. And when you are finished, hopefully you find that you get 6 for the integer and then 6.2 for the nearest tenth. And again, if you didn't get that, bring your questions to class the next time I see you. All right, so here we're comparing. It says, which is greater, radical 18, or I should say or, there's my mistake of the day, or 4.4. All right, so here there's a couple different ways to do this. First is, anytime you're comparing numbers, now this is an opinion thing, but anytime you're comparing numbers, I think it's easier to get everything to the decimal form. So for radical 18, you could go through that same process that we just did and figure out what it approximates to. So I have radical 18, or the other option that you could do is put it in your calculator and round it to the nearest tenth. When you do that, you find that radical 18 is just about 4.2. Okay, so if radical 18 is 4.2 and I'm comparing it to 4.4, it says which is greater? Well, that would have to be the 4.4. Okay, so again, convert them to decimals. That's going to be your best bet for doing these kind of problems. Here's one for you to try on your own. Give that a shot, pause, and do the problem. And on this one, the larger value is going to be 4.7. And here I have another typo. Got to change that later. So 4.7 is the greater value for this particular problem. All right, let's take a look at an application of these different finding square roots. So here it says the formula S dot A, that stands for surface area, equals 13r squared, approximates the surface area of a sphere with a radius of r. It says find the radius of a sphere with a surface area of 780 square units. So in order to do this problem, we're going to have to go back and remember a little bit of our pre-algebra from last year. I'm going to substitute in 780 for this SA. So I have 780 equals 13r squared. Now, in order to do this, the next step that I got to do is to get this by itself. Remember, when you're solving for a variable, you're trying to isolate the variable. So my first step is to divide both sides by 13. These 13 simplify out, and they're gone. And then on this side, I'm left with 60. Okay, and this is an approximation, but it's close enough for this. If you notice everything else, this 13 is an approximation, for instance, to find the surface area. So 60 is just about the radius squared. So the next step to do would be to undo squaring a number. All right, to undo a square, you find its square root. And then we'll talk more about properties of quality as the year goes on. But if I find the square root of this side, in order for this sign to stay true, I have to also find the square root of this side. And when I do that, I get approximately 7.7. So the radius is going to be 7.7. All right, so again, you set up your equation by substituting in the surface area here and then solving the equation, going through steps that hopefully you remember from last year. If not, we will be spending more time on this later in the year, so don't fret too much. Here is one for you to try with a surface area of 520 square units, so go ahead and give that a shot, and hopefully you find 6.3 as the approximate answer for that. Let's go on to our next thing. All right, I got a couple other vocabulary words, so here you want to pause and make sure you write them down. Irrational numbers are numbers that cannot be written in the form of a fraction, okay, where A is any integer and B is any non-zero integer. They cannot be written around that way. So some common examples would be, everybody knows the number pi. It's 3.1415 and goes on forever and ever. That is a number that does not repeat at any point, and it does not end. It's a non-terminating, non-repeating decimal, and that's what makes it an irrational number. Another example of this would be, for instance, the square root of 3. Okay, the square root of 3 is some value that goes on forever as a decimal, and it never repeats, and it never ends. Rational and irrational numbers form a set of numbers called the real numbers. Now, oftentimes I get students kind of laughing at that, and you're like, how can you have real numbers? Well, eventually, you'll get to Algebra 2, and you'll learn about numbers called imaginary numbers. And no, I'm not making that up. That is a real thing. But how do these things apply? Well, for now, what I want you to do, we have a couple diagrams that I want you to copy down. This first one is a Venn diagram, and this kind of gives you an idea of how these numbers match up with one another. And then over here, it breaks it down in a different way. So go ahead and copy this down, pause and copy it. And then when you're done, play again. But here within the rational numbers, remember, rational numbers are numbers that can be represented as a fraction. So numbers that can be represented as a fraction, the natural numbers are the counting numbers, 1, 2, 3, and so on. And any of those can be turned into a fraction by putting that particular number over 1. The same can be said about whole numbers. The only difference between whole and natural is that the whole numbers have 0 and natural numbers don't. But any of those can be turned into a fraction by putting it over 1. And then on to integers, which is all the whole numbers plus the opposites. So -1, -2, and so on. And again, those can be turned into a fraction by putting it over 1. And then out here in this space, you have all the other fractions that don't fall into these categories, like 1/2 and -2/3 and so on. Those are the rational numbers. Over here are the numbers like pi and the radical square 3 that cannot be written as a fraction. Over here is another way of looking at it. The rational numbers contain the integers, which are all these values that we just talked about, any fractions, and then terminating and repeating decimals. The irrational numbers are square roots of values that are not perfect square or any kind of weird decimal that you may get. All right, so there's your two different categories of numbers. It says, is each number rational or irrational? This one would be irrational because it does not have a repeating decimal. This one is rational because the 8-1 repeats. This is rational because it's a fraction. And then this one would be irrational because it is the square root of something that's not a perfect square. And that's the end of the show. See you in class.